Hi there! In today's video I'm continuing with my OKGPT project in which I'm creating a Google Home or Alexa style device that is voice controlled. And in the previous video I already implemented the wakeup key phrase. So when I say OKGPT, then it recognizes that and then we can start to listen for the actual command that we want to give. Now I originally did the wakeup key phrase detection with the PocketSphinx library for Python. And the reason was that this was the only one that I knew that worked locally, not with some API. Because of course I don't want to send all of the audio from my device to Google or OpenAI. Until of course I actually want to talk to it. Now if you saw the previous video, then you know that the PocketSphinx is not a very good voice recognition library. Now in a perfect world, how it should work is we should use this live speech to do the key phrase detection. So we actually have a method of doing exactly that with PocketSphinx. So basically you just initialize this live speech and you give it the key phrase that you want to listen for, and then you just listen for it. And then here, instead of printing it, you can actually do whatever you want after you get the key phrase. But it doesn't really work. So in the end, what I had to do is, first of all, I had to create this init.py, which asks us for the key phrase 10 times. And it will listen to it with the live speech. And it will save the words that it heard, which usually are different words even though you say the same word 10 times. And then we just save those phrases into a file. And then we have this recognize.py, which reads the phrases from the phrases.json file, and then it listens for all those words. Now what I had to do is I had to create this multi-processing wrapper for the live speech of PocketSphinx. So basically we have one function that will listen to one word with the live speech. And then we have another function that takes a list of words and then opens a new process for each of those words with this listen word function. So we are actually listening to all of the keywords at the same time, because as far as I know, this was not possible with the PocketSphinx by default. And then we just listen. We have this queue into which we push a message when we hear any of the words. So then here we can detect that we said something, and then we can put our code here to do something after that. So let me actually check if this still works. Now we have two different errors that we sometimes get, so this is not great. But let's try to do Python 3 recognize.py. And in fact, this is the first error that we get, and I'm not sure why this happens. I'm guessing it has to do with this multi-processing. So maybe we cannot create a process for all of these words to listen to the microphone. And as you can see here, we already detected 4 times our keyword, but we didn't actually say it, so this is not that amazing. But technically, if I say OKGPT, then it actually detects it. And every time I say OKGPT, then it detects something. So at least it works somewhat okay. Now we can of course change this KWS threshold here and maybe make it better. But in today's video, what I would like to do is I would like to actually implement the usage of the OpenAI Whisper API after we get the initial keyword. So basically, when we say OKGPT, then we should start listening to the audio and then send that audio to OpenAI, to the Whisper API. And actually, the OpenAI Whisper is apparently open source, so we could perhaps even run it locally. And based on the comments on my previous video, it is actually possible, and we can even do it on a Raspberry Pi. Now, there's also this Mozilla DeepSpeech, which apparently also works locally. And it even says here in the description of the GitHub repository that it will work with the Raspberry Pi 4. So we might in fact try to use one of these and maybe even use that for the initial detection. But let's now try to use just this implementation for the initial keyword, and then let's start to listen to the actual command after this. And I'm okay with sending that to OpenAI or Google or whatever. But if we can do it locally, then that would be pretty amazing. So let's actually check out this Whisper first. because at least the API works really well. So let me actually search OpenAI Whisper Python local. Is there some way we can use this locally? Okay, how to run OpenAI's Whisper speech recognition model. So let's see if we can somehow easily do it. And actually here they are mentioning some other libraries, so we might check these out as well if this one doesn't work. But anyway, how do we install this? Okay, we have to install FFmpeg. I of course have that installed. And what else? If using Windows, I'm not using Windows, so I'm not going to do that. And we have to install Whisper. Oh, I can pip install Whisper straight from the GitHub repository. That's pretty cool. So let's try to do that. Let's install it. And that is awesome. So does it directly work just like that? Okay, while this is installing, let's check out what we have to do then. Okay, so we can just run Whisper with some audio, and then it will transcribe it. What? Is it this simple? No way. So here's a Python example. So just import Whisper and load the model and transcribe. What? So previously I looked at the GitHub repository and I saw that they were talking about Torch somewhere. Yeah, PyTorch. So I thought this is going to be very complicated. I have to do some AI stuff. But apparently it is not complicated at all. So is this installed yet? Not yet. So let's wait for a while. Now we are actually installing CUDA as well. So I'm not sure how well this will work with a Raspberry Pi. So let's actually check out the DeepSpeech as well. So how do we use this? Let's just Google Mozilla DeepSpeech Python. And what do we have here? Okay, let's go to read the docs. Do we have some example code? Please give me some example code. I do not have any example code. Using a pre-trained model. So this is also like a neural network or something. Okay, and here we have a Python package. So can we just install DeepSpeech? Okay, yes, we can in fact do that. And how do we then make it work? Please ensure you have the required CUDA dependency. Okay. Now, they said that this works with Raspberry Pi, so I guess CUDA works fine on that. Or maybe it's just an option if you want to use the GPU version, but maybe you can also run it on the CPU. Okay, you have to download the pre-trained model, okay. And here we have a link to the Python client. So this seems way more complicated, but we're still installing Whisper. And I really should have created a virtual environment because now I'm installing all of this stuff on my computer. But let's actually check if ChatGPT knows how to use this. Can you give me example code of how to use the Mozilla DeepSpeech to transcribe text? Okay, so here is an example. All right, so we just import DeepSpeech and we load the model, okay, and we have some sort of scorer, and then we open the audio, and then we assert something, and then we do the speech to text. Okay, so I need to find the model somewhere. But is this already finished? All right, it is finally finishing the installation. So let's see if we can use the Whisper API. All right, we have finally installed Whisper. And I also found the download links for the model and the scorer. So let's download those as well. So I'll just do it here. And how big are these? I think a few 100 megabytes. And let's actually figure out how we can record audio with Python. So actually I will just ask ChatGPT, how do I record audio from the microphone in Python and save it into a file? Now, maybe there is something like this in the Whisper library or the DeepSpeech library, because actually I still have to detect when the speech starts and when the speech ends. But actually we can also use the PocketSphinx to do that, because in the previous video I noticed that when I keep speaking, it never produces any output until I stop speaking. So basically we could use the PocketSphinx to detect when we are speaking. but that seems kind of stupid to use all of these different libraries, but let's see. That is very complicated. So we have to set all of these kind of things, and we set how many seconds we're going to record, and then we are going to open a stream, and then we are going to record and stop and close and terminate, and then we're going to write into a file. Let's see if this will work. So if I copy this, and I will create a new file, record.py, and I will paste this in here. And I think I have Pi audio already, and I have wave, and we record for 5 seconds, and then it is output.wave, and let's just try to run this. So Python 3 record.py. Hello there, this is just a test, and I am talking something stupid to the microphone. Okay, so let's see if it actually worked. We didn't get any errors, and we have output here, which gives an error in the web view of VS Code, but can we actually open it in the folder? And let's try to open this wave file. And let's play this. Okay, it actually worked. Now, you probably can't hear it. It was very quiet because it is not actually recording this microphone. It is recording my laptop microphone. And it's very echoey. So it might in fact be the reason why the detection was so bad, because this sounds horrible. Let me see if I can make it so that you can actually hear something. Hello there. This is just a test, and I'm talking something stupid. Okay, so it's very echoey and bad, but we actually were able to record it. So let's try to transcribe that. So let's create a Whisper transcribe.py. And here, let's do the thing that we were supposed to do. So this, and just paste this in here. And this is going to be output.wave. And let's just print result. And let's run it and see if we can actually do it. So Python 3 Whisper transcribe. And we are downloading something. So I guess it will download the model from somewhere. Okay, so I'm sure we don't have to do this every time, so just the first time we have to do this. Okay, and we actually did it. So we have the text here. Hello there, this is just a test, and I'm talking something stupid. So that is exactly what I said. So we can get from that, I guess, the text. So if you get just the text, then it should be just this. And we got some warning here, because we are running this on CPU. So I'm not sure how we can suppress this. Let's see. If dtype is torch.float16, then we have to set it to float32. So can we set the dtype? How do we set it? Decode options get fp16. So where do we set decode options? Let's see. This is a transcribe function, and that is exactly this. So we can set here decode options. If I can again reload my VS Code so that it will actually have auto-completion, decode options, and I can set a dictionary, and I can say fp16 is false. So let's try to run this again, and we again got the same error. Oh, was it decoding options? Wait a minute. It is decode options. Oh, this is star. So we have to just say fp16 equals false, I guess. So let's try to run this one. Okay, and we didn't get that error, but we have to call it like this. So it's a dictionary. So let's run it one more time. And now we just get, hello there, this is just a test and I'm talking something stupid. So now it works, and we're actually using it locally. So that's pretty cool. So we are not going to use OpenAI Whisper API, although it might be beneficial to show how that works as well. Now, does Whisper have something like the live speech of PocketSphinx? So is there like Whisper dot? What do we have here? Do we have some sort of live thing? We probably don't have it. So you're supposed to implement that yourself. So how should we implement that? So let's take a look at our record.py. So how does this work? We initialize all these things, and we set the record seconds. And then here we do this loop based on the record seconds, and then we read a chunk. So could we instead use some other way to detect the end? So if this would just be while true, then we would be recording indefinitely. But then we should be able to detect the end of the speech and then we can stop it. So how do we do that? I mean, I guess since we are reading the stream, then couldn't we read like the volume level? And then we could say that when the volume level goes below some threshold for long enough, then we're going to stop. So is there something in here? Data dot. Is there like a volume? Or what do we have here? What is this actually? Why do we have like is lower here? Is it like a string? Let's ask, how do we get from this the volume level? Or is it actually in the stream? So how do I get the volume level from this? Okay, so we have to do this. So what did it say? To get the volume from this, which reads raw audio data from the stream, you need to convert that data into a format that can be analyzed for volume, loudness. A common approach is to interpret the raw audio frames as an array of samples and then calculate the root mean square RMS value. Okay, so we imported audio OP. Did we include that last time? No. So let's actually copy this code and paste it in here. And that is not actually the full code, so we actually have to copy what we need. So let's change these imports, and we have to install audio OP, maybe. So pip install audio OP. Okay, maybe it comes directly from the standard library. So what we then have to do is we have to get the RMS from the data, and then we can just print the RMS. Okay, so let's actually see what happens if we do that. And let's just say RMS is this. And I guess we can just do this and we can see what kind of numbers we get from that. So let's run Python 3 record.py. And now if we talk, actually I have to talk there. So when I don't say anything, then we are somewhere below 200. But then when I talk, it goes over 1,000. So could we do something like this? Let's not print this recording here. Let's only get the RMS. And then we can say if RMS is greater than, let's say 200, or let's say 300, then let's say that recording is true. And let's define that here. Recording is false. And then if RMS is less than 300, well, I guess we can just say else. So else or if recording is true. So if we are below 300 and we are recording, then recording is false. And I guess we can just say if recording. And then we can say here, if not recording, then we are going to print started recording. And then here we are going to print ended recording. And if we are recording, we are going to append the frames. And then we can remove that as well. And when we end the recording, we are going to do all of this stuff. So then we're going to save it. So let's do that here. And let's set the frames to an empty list again. And let's add here like an underscore and the string of audio number. And let's set audio number to 1. And when we save it, we are going to say audio number equals or plus equals 1. So now we should save a file for each of the times when we speak. So let's see if that will work. So I'm going to say Python 3 record.py. And if I start speaking, we actually started recording, but then we got an error. We got a stream closed. Why did that happen? Sorry, I put this in the wrong place. So this, of course, has to be when we end the recording. So here we're going to do this, and then we're going to say ended recording. So let's try this again. Hello there, this is something. Okay, and we actually ended the recording again. So we probably went under the 300, but we should have some sort of timer that we have to go under 300 for a long time. So for now, before I start to actually read some timings, I will just say I equals 0 here, and I will say here I plus plus, or I plus equals 1. And when we start recording, then I equals 0 again. And if we are recording and we go below 300 and I is greater than, let's say, 300, then we stop recording. And actually I has to be 0 every time the volume goes above 300. But we should change this to like an actual timing. But for now, let's do this. Hello there, this is just a test, and now I am speaking, and when I stop, this should be saved into a file. Okay, and we actually ended the recording, but 300 was way too much, so I'll just say like 50. But why is the stream closed now? Stream.stopstream. Because we shouldn't stop the stream here. We should only save the recorded data, so the frames. And then down here, we have to just stop recording after we finish this loop, which we'll never finish at the moment. So really, we should have actually wrote the file, but that is not actually how I should have named it. So I have to add here .wave and wave output file name. I will just call this output, and let's actually make this an F string. So output and the audio number and .wave. So actually the error we got was from when we started to record again, because we closed the stream already. So now it should work. So let's try it one more time. Hello there, this is the first recording. And this is the second recording, but actually now we just say ended recording all the time. So I have to set something. I have to say that the recording is false. I set recording to false, recording. And now we have 100 different files here. So let's actually delete some of these. Okay, let's try again. Hello there, this is the first recording and I am recording just something. Hello, this is the second recording and now we are going to make output 2.wave. Hello, this is the third recording. And finally, let's make a fourth recording, because why not? Okay, so let's listen to this. Does this actually work? So we have 4 different files. So let's see how it sounds like. Hello there, this is the first recording and I'm recording just... Okay, that was a bit weird. We didn't record every single frame, apparently. Let's listen to the second one. Hello, this is the second recording and now we are going to make output 2.wave. Okay, that sounds very weird. I did something wrong now. Okay, so actually, we should record every time when we are recording, not only when the RMS is over 300. So let's move this frames.append down here, and let's say if recording, then we are going to append the frames. So let's try again. Hello, this is the first recording, and now we should make file number 1. And we already had file number 2, 3, and 4 in there, but this should replace them. And then let's make file number 3. And finally, file number 4. Alright, now we have, again, 4 files, and let's listen to them. Hello, this is the first recording, and now we should make file number 1. Okay, the first one sounded fine. Let's see the second one. And we already had file number 2, 3, and 4 in there, but this should replace them. Okay, and that sounds good as well. And I guess we can try the next one too. Let's make file number 3. Alright, and finally, the fourth one. And leave file number 4. Okay, it works. So now we can actually detect the recordings ourselves. So maybe we can actually now use Whisper for the initial detection as well. So let's do this. Let's import our Whisper in our record.py. And actually, I don't think we use this square root. I think ChatGPT told us that we can calculate it somehow. Oh, we can change it to decibels. Okay. But I'm not sure if we want to do that. or need to do that. But let's import Whisper, and let's then, after we have finished the recording, let's transcribe the recording with Whisper. So let's do that. So in our Whisper transcribe, we did it like this, and then we got the result. So let's actually create like a function here. Let's do transcribe. I think we can just do this. And then we give it the audio file. And it will do this. It will load the model. Now, do we want to load the model every time in this function? Probably not. So I guess we could just define it here as the Whisper model. And then we can just say Whisper model.transcribe. And then we can return this text directly. Now, a better way, I guess, would be to pass it in here. So Whisper model. And then we can say that this is the audio file. So this is a little bit of an easier wrapper. Or we could actually create our own module. So let's call this like transcription.py. And here we can import Whisper. And we can make this function. And then we can actually do just this. So then what we can do is we can say from transcription import transcribe. So then we can just call transcribe wherever we want to transcribe some audio. So let's do it here. Let's not create this audio number. So let's remove that. And let's just put it in one file. So let's call this just audio.wave. And then we don't have to increment this. But after we save the file, then we are going to just print transcribe. And we are going to pass in the audio.wave. And I guess this doesn't have to be an f string anymore. And I guess we can do os.remove audio.wave. So we don't have to actually have this file left anymore. It's just a temporary file. So let's import os. Okay. So now we should actually echo out everything we say. So let's see how fast that actually is. So if I now run Python 3 record.py, then if I say something now, it will record it. And as you can see, it transcribed it. And it took a couple of seconds to do it. So this is actually pretty cool. So what if we now say the following phrase? Okay, GPT. It actually recognized it, although it was GBT and not GPT. But now we're actually recording and then transcribing everything we say. So I guess we could now detect OKGPT with this as well. Now I'm going to change this I greater than 50. And I think I actually can just use this iterator number here because we are actually reading a chunk. And I guess the chunk is going to be the number of frames. So it is going to be time-based. So I guess we can use this. So I will just put like 20 here. Maybe that's enough. I'm not sure what that means in seconds, but let's just use 20. But the thing is now, as you saw there, it detected it as OKGBT. So I wonder how many different ways this can detect what we say. So how can we then, if we transcribe it, how can we compare it to what we want it to be? Maybe we have to do some similarity analysis or something. Now, we could do it with ChatGPT, but I don't think that is a good idea, because then we have to make a ChatGPT request every time we say something. But let's actually try and say OKGPT a few times and see what it detects. So I guess we can do the same kind of initialization as before. So let's see. OKGPT. OKGPT, 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 OKGPT. All right, so that is actually pretty accurate. So it is either GBT or GPT. So how should we do the recognition? Let's first of all make this 10. I think 10 is enough as the delay between the recordings. Now, maybe we want to change this. So maybe for the initial detection, it's 10, but then when we actually get the longer command, then we want it to be bigger. But let's do that. And let's create some sort of function that can compare the transcription with some word that we want to use as the key phrase. So should we make it in the transcription module? So if we say something like is similar or something like this, and we have word 1 and word 2, then how could we compare them? So if we pass in like a word or phrase, OK GPT, but then actually it comes out as OK GBT, then how do we compare these? Well, first of all, we should say that word 1 is word 1.2 lower. Is it this way? Again, I have to reload my window. Or is it just lower? No, it's 2 lower. Or lowercase. What is it? Word 1 lower. 2 lower. I guess I have to say that it is a str. So then I can say word 1, 2 lower. Lower. Okay, just lower. And word 2 is word 2 dot lower. And then we probably want to get rid of the commas. So should we make like a regex? So could we say that the word 1 equals re dot something? Let's import re for regex. And is there replace? Re dot, how do we actually replace sub split search? How do we actually do this? It's sub, I guess, for substitute. So what is this? Pattern, replacement, and string. Okay, so the pattern will be like a raw string, and it is going to be not A to Z and not space. All of those will be replaced with nothing. And we pass in word 1. And I guess we can just do this to make it a little bit shorter. And then we can do the same thing with word 2. So now we should only have lowercase letters and spaces. And then how do we detect GPT and GBT? Now, Whisper is pretty accurate, so maybe we just pass in OKGPT and OKGBT as the detection. But then if you want to change this, then I don't want to have to actually add all the combinations. But still, if we did the same kind of initialization that we have to say 10 times, then maybe if we just get those different versions, then we can just detect that. So then it would be enough to make it lowercase and remove other than lowercase characters. So then we could just say that is similar will return word 1 equals word 2. And that's it. And then I guess we could pass one of these as a list, or maybe even both of them as a list. And then we can say if is instance word 1 list, or if not is instance word 1 list, then we are going to say that word 1 is a list of word 1. And we're going to do the same thing with word 2, and then we can say for word in word 1, we are going to check for word underscore 2 in word 2, and then we're going to do this stuff, and we're going to do it for this word. What should I call this? Let's call word A and word B. So then word 1 is going to be word A, and word 2 is going to be word B, and then if word A equals word B, then we are going to return true, and down here we are going to return false. So a very unperformant function, but I think we're not going to have that many words. So basically we can pass in either a single word in this or a list of words that we are going to compare to another word or list of words. And if any of them match with any of them, then we're going to return true. So then we can do something like this. We can say status is, let's just put a string for now. Let's just say wait, wake up. And then what we can do is we can say that the transcription is that. But can we use transcription when we have such a module? So let's call it message. So we can say if, and actually we remove this afterwards right away, if status equals wait, wake up, then if message is similar, so is similar, and we are going to import is similar from here, if the message is similar to OKGPT or OKGBT, then the status is going to be listen command. And then else if status equals listen command, then we're going to print got command. And let's put in here the message. And this is an F string. And here let's print listening for command. And we can remove this ended recording from here and started recording. And in fact, this as well. And then when we get the command, we should set the status to wait wakeup. So now, if we run this again, Python 3 record.py, then if I just say something, then nothing happens. But if I say the correct keyword, which is OKGPT, then actually it didn't work. So what went wrong? And I also realized that I can't just check OKGPT because we might actually have something else in the message. So let's actually print here the message. And why didn't this work? For word A in word 1, for word B in word 2, word A is RE sub, this replaced with nothing, word A lower, and word B lower. If word A equals word B. Okay. Now actually I have to trim this as well, because there might be white space in there, because I allow spaces in there. But still, this is not actually going to work. I should say something like, if word A in word B, because we want to look for the word A inside of the word B. So actually the other way around. So we can flip these around. This is a terrible function. What am I doing here? But anyway, if in the word B is this or that, then it should work. And let's actually print these things. Let's print checking word A in word B. And let's do it again. So now if I say just something, we are checking OKGPT in so no now if I say just something. And I think that was exactly the problem because we have a space here. So if I now say OKGPT, then we actually detected OK like this. All right, that was my mistake. So I have to actually use OK. I guess I could add all of those combinations here. I can say OK and OK here. So now it should work. So if we now run this, so if I now just say something, then nothing happens. But if I say OKGPT, then now we are listening for a command and it should say it, and here we got the command. So I should actually add more of a delay when we get the command and we listen to the actual command. But now, again, if I say OKGPT, then we listen for another command. And it didn't quite work properly because it said comment. But again, my microphone is over there on my laptop, so it's not that great. And it's very echoey, so actually it's doing a good job. But again, we can say OKGPT, and then we can say something it has to do. And then we could send this command to ChatGPT, and then we could get a response back. So let's do a couple of modifications. So first of all, the time it waits here, let's actually call this wait time. And let's set wait time to 10. And then we can say if status equals wait wakeup, then wait time is 10, and otherwise wait time is 50 or 60, something like this. So when we wait for the wakeup keyword, we wait just 10 some units. I'm not sure what units these are. And then when we actually listen for the command, we wait 60 units. So that should work a bit better now. So let's try again. Okay, now I'm just talking something here and nothing should happen. But if I say OKGPT, then now we are listening for a command. Now, it did take quite a long time for it to detect the OKGPT. So let's see how it works with the actual Raspberry Pi, if it's even slower. Or maybe we can do something to make it faster. And maybe I should add OKGBT like this as well. So now we are actually doing our own detection of the audio levels. So if we want to use something else, like the deep speech, then we only have to change this transcribe thing. So that's pretty cool. Let's actually try to use the deep speech. So let's see if ChatGPT's example works. So let's copy this whole thing and let's make a new file called deepspeechtranscribe.py and paste this thing in here. And I have to do pip install deep speech. And we actually didn't find it. So how do we install that? How do I install the deep speech Python package? Okay, I should be able to do that. pip3. Do I have to say pip3? I'm not sure. I don't think so. pip3. Deep speech. Did I write it correctly? Pip install deep speech. Okay, so that's a little bit of a problem. Let's say no matching distribution found for deep speech. So let's see the actual documentation. What did they say here about it? Okay, so we have deep speech or deep speech GPU and deep speech TF Lite. So do we have deep speech GPU? Let's see, deep speech GPU. And I'll just use pip install. We don't have that either. So how to install deep speech Python package? So we actually have it here, but why does it not work? Can we somehow download it? Download files. Build distributions. Okay. How do I install it from this? Let's ask ChatGPT. Can I install it from a WHL file? Yes. Okay, so we just do pip install. So which one should I take? So let's copy all of these and let's say I'm on Ubuntu 22.04, I guess. Which WHL of these should I pick? And let's paste them here. Okay, many Linux 1, x86-64. So let's do that. Copy link address and let's just do wget this. And pip install deep speech cp39 and so on. Is not supported wheel on this platform. Okay. Sorry. I have Python. What is my Python version? I have 3.8. So I should actually pick this one. So copy link address and actually remove deep speech cp39 and wget this and pip install deep speech cp38. And this doesn't work either. So Python version, I have 3.10. Okay, so that is the reason why I can't install it. So how do I install an older Python? How do I install an older Python version? Okay, method 1, using Dead Snake's PPA. So let's try to do this. Let's add this repository. And then let's install sudo apt install Python 3.9, I guess we could install. And then we can actually probably install deep speech. Now, I'm not sure how we actually run a specific Python version. Can we just run Python 3.9 from the terminal? So what if I do just Python 3 version? We still have 3.10. Can I do Python 3.9? I can. So what if I do pip 3.9? Can I do that? Pip 3.9 install deep speech. No. What if I do pip3 install DeepSpeech? How about pip install DeepSpeech? Okay, how about I now run this one from the WHL file? No, how do I pip install for that specific Python version? So let's say I have installed Python 3.9. How can I pip install packages for it? I mean, maybe I know. Is it something like Python 3.9 m pip install DeepSpeech? No module named dist-utils cmd. Can I install this one? cp9, but I deleted it already. So let's download that one now. So this one, wget that one, and then do this cp39. Okay, well, how do I do this? So exactly like this, but do I need to upgrade pip for that? So let's run this. Dist-utils. Do I have to install that? But how do I install dist-utils? Damn it. Let's paste this in here. Okay, so I have to install this one. Alright, and then I can run this thing. And now we are actually installing it. Okay, so it's installed. That was really fast. Maybe we used some of the same things as in Whisper. Oh, wait a minute, this is for 3.9, so do we only need NumPy and DeepSpeech? That's pretty cool. So now we should be able to do this. And I already downloaded these files, so I have to import Wave, I can see. And let's just load, let's say output.wave, and then we should print the text. So let's see if DeepSpeech works. So if we now run Python 3.9 DeepSpeech transcribe, then will it actually work? Okay, we got invalid sample rate, so we have to change the sample rate. Hopefully we can use a different sample rate. Wait a minute, we can't. Can we set the sample rate? Model dot, well, it doesn't now know because DeepSpeech is not found. Let's copy this error and see how we can actually fix that. So am I still in the same thing? Yes. So let's actually edit this question and just add the assertion error here. Okay, so I have to resample my audio to 16,000 Hertz. Okay, let's see if this one will work. So let's change again this, let's call this resampled audio. And this one is going to be the output.wave that we have there already. And I have to install PyDub. So let's do Python 3.9 m pip install PyDub. And let's pip install PyDub just locally as well, or for the latest version. And let's try this again. So let's run DeepSpeech transcribe. And we got invalid literal for int. Okay, so first of all, we got some sort of warning here. So I feel like I am not going to test this any further, because this seems like it is like a deprecated product anyway, because we don't have it for Python 3.10 anymore. So I am going to have to test Whisper on a Raspberry Pi and see if it actually works. So let's now actually convert our previously created init.py and our recognize.py from PocketSphinx to Whisper. So let's start from init.py. So here we basically listen for a word 10 times, and then we save all the phrases we heard into this phrases.json file. So could we actually make this kind of generator from our Whisper version? Let's see if we can do it. So we can define a function that is listen words. Let's call it listen words. And let's put this whole thing in here. And we actually don't need this record seconds because we are not using that anymore. And I think the way generators work in Python is that you use the yield keyword. So I will yield the message here, and I'll actually trim the message as well, because there's usually the space in the beginning. And then we can move this status handling somewhere else. So let's actually copy our status stuff from here. We don't need it here. And I guess we could pass in the wait time as an argument. So let's say wait time. And let's default it to 10, for example. So now we are going to yield these messages from this generator. And let's copy this code somewhere safe. And I think I won't have this transcription module anymore, because it's just this simple wrapper function. So instead, in record, I am going to just say this. When I call transcribe, I am going to do this directly. So I am going to say that the Whisper model, which I can just call model, is whisper.load. And then I can say result is that, and then I can say message is result text. And we can just import Whisper. So that is pretty simple. An audio file is just audio.wave. And I don't need this transcribe at all. And then the isSimilar function, I guess I can just move that in here. I don't need a separate module right now. So let's just do that. So then in our init, we can import record. Let's just call it record now, because that's what I called the file. And we can remove the PocketSphinx import. And we are going to say for phrase in listen words. And we have to actually do from record import listen words. So now it should work just the same. Now, we should remove duplicates. Can we do something like phrases equals unique? Is there some way to make a list unique? Not sure. I mean, we could just have a dictionary, and we might say that phrases index this or key this is going to be the phrase. Or it can just be one. And then we can say phrases dot keys. And I guess keys is going to be a list. It's going to be dict keys, which I hope is a list. Can we say list? Maybe this is terrible Python code, but it should work. So let's see if it actually works. So does this still look fine? It looks fine. So let's run this thing. Python 3 init.py. Okay, GPT. Okay. str object has no attribute trim. Wait a minute. Oh, it's called strip. Strip. Okay, let's try one more time. Okay, GPT. 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 All right, so we actually got quite a few different versions. So we got this Chinese version, and then GBT and GBD and TBT, and all kinds of different versions. So now we should have saved them into phrases.json. And here they are. Okay. Now, there's a problem with this Chinese version, because we strip everything that is not alphanumeric. So now OK is one of the things. So we still have some problems to figure out. But then let's try to do recognize.py. So we are not going to have live speech anymore, and we don't need multiprocessing. And basically what we should do here is we should read the phrases.json file, and then we should detect keyphrase. So we should do something like while true, we are going to print detecting keyphrase, and then we can say for phrase in listen words, and we have to import from record import listen words. And we can just listen for one word, and then when we get a word, we should say if is similar, and we are going to say phrase and we are going to pass in our phrases. Then we are going to break, and we can print here detected, and let's pass in the phrase. And now we can put our isSimilar function in here. So let's copy it from here. And I will remove my regex for now, because it is going to break that Chinese version. And then, sorry, I put this in the wrong file. This should be in recognize. So now, if the word is similar to one of the phrases, then we detected that. And that means that then we are in the mode for detecting the command we want to run. So then we can say again for phrase in listen words. And now we can pass in here the wait time as 50. And then we can just say that we detected a command. So command is going to be the phrase. And that's going to be it. Then we're just going to go back here, detecting keyphrase. And I guess I can just print this here now, just one time. So we only get detected and command. Now, I think we are initializing Whisper every time with listen words. So let's actually go to record. How does this work? We are creating the model here. So actually I'm going to say that this is Whisper model, and I'm going to just define it here as a global thing in this module. Whisper model. All right. So now we should not have to initialize Whisper every time when we call listen words. Now, I'm not sure what happens when we yield something and then we break. Then we're actually not ever going to stop recording. How can we actually do that? I'm not sure. Maybe there's some sort of command you can give in a generator that when you end it, it will clean up something. But let's see if this will now work. So let's run Python 3 recognize.py. And now we are detecting the key phrase. So if I say, OK GPT, then we detected it. And if we now say something, then this should be the command. And it actually works. And now if we say again, OK GPT, then we detected it. And this is now again the command that we will run. OK GPT, turn on the lights. OK GPT, this time it didn't detect it. OK GPT, cook me dinner. Maybe that's too much to ask. But yeah, now it's working. So we just have to add a few more phrases into this detection, or make it somehow detect variations better. And we have to make sure that we close all the streams. Maybe if we use this for long enough, then something will happen. Maybe we run out of memory or something. But yeah, now we have a Whisper version of the previous PocketSphinx version. So this is going to be the end of today's video. I hope you enjoyed it. And if you want to see the next video where I integrate ChatGPT into this, then make sure to subscribe to my channel. And of course, leave me a like and let me know your comments down below. And I'll see you in the next one.